Lecture 7 is an introduction to probability models. In order triple, S script A P defines the probability model entirely. S is the sample space or outcome space, so it's the set of all possible outcomes of some experiment. For example, if you flip a coin, assuming that it doesn't land on the edge, then your sample space is going to be H or T, where H stands for heads and T stands for tails. The whole sample space is HT, but the sample point is just the single heads or tails. If you roll a dice, what are the possible outcomes? 1, 2, 3, 4, 5, and 6. So that is your sample space, and one of those is called the sample point. Script A is the collection of all subsets of the sample space. So remember here previously, here we had S is our 1 through 6 and S is our HT. So this is our sample space. So what script A is just all subsets of these. A subset is called an event, which is denoted by E. For example, if we flip a coin, what are the possible subsets? Remember, our sample space is the whole set HT. So what are possible subsets of that? You could have H, you could have T, you could have the whole sample space, which is HT, or you could have the empty set. When we rolled our die, remember the sample space was 1, 2, 3, 4, 5, 6. So what are all the possible events? What's the whole collection of sample space? So then you can have all different combinations. Well, let's look at just some of those. So what is the event that a die roll is even? If the die roll is even, then your event is just the 2, 4, 6, which is one of the subsets. The event that the die roll is less than 5, you have the numbers 1 through 4. The event that a 6 is rolled is just the event that contains the one number 6. All of these events here is a subset of our sample space. So all of these E's can be found in this script A. We can combine events, any event E that lies in the set script A, by unions, intersections, complementation, just like you have learned in the past. So the complement of a set, so if we talk about a set E, the complement is everything that is in our sample space but does not lie in E. So again, this is going to be a subset of script A, or an element of script A, sorry. So here the complement is everything that is in our sample space but that is not in E. Union is just what you think. If you have a union of two events, E1 and E2, then the union is everything that is in at least one of the two sets. So the combination. The intersection of events E1 and E2 is everything that is in common between each of those two sets. Two events are called disjoint or mutually exclusive if when you intersect them you get the empty space. So basically you have two different sets, there's nothing that's in common between the two sets or events. E is said to be a countable union if basically you can write E as a union of countable sets, countable events. And E is called a countable intersection, again, if you can write E as a countable intersection of events. Our partition S is where you can write S as the union of events, let's say E1 through EK, so that all of those events are disjoint. So they don't overlap, but basically their union is the whole sample space. So they would have S here. The union is the whole sample space. Okay, so the formal definition of script A. Again, we said it was a collection of subsets in S, and it's called a sigma algebra, and the ordered pair, the sample space with the script A, is called a measurable space. If here our sample space is an element of our script A, if any event is in our script A, then the complement is also in script A. And if you have a sequence of events in script A, then their union is also in script A. So going back to our probability model, we had our sample space. Remember, that was all of our possible outcomes. We had our script A, which is the collection of all events or all subsets of our sample space. We also have P. So we need to talk about the P part, the probability measure, in our probability model. The probability measure assigns some probability to each event in script A. So it's what's the probability of that event happening? P goes from our event space to 0, 1, so the probability has to be less than or equal to 1. But the probability of any event is always greater than or equal to 0. The probability can be equal to 0, so there could be probability that the event cannot happen. Probability of the entire sample space would be 1. And if you have two disjoint sets, E1 and E2, then you look at the probability of the union by just summing each of their individual probabilities. So these three axioms are called the axioms of probability, and we'll be looking at a lot of different rules for probability measure using these axioms of probability. So again, probability goes from our script A set, so the probability of an event, and it's a function going from our script A to 0, 1. Probability of any event has to be greater than or equal to 0. If you look at the entire sample space, the probability of the entire sample space has to be equal to 1. And if you have any two disjoint events, then the union of those, the probability of the union, is just the sum of individual probabilities. So for example, flipping our coin, our sample space was HT. So if the coin is fair, we assume there's an equal likelihood of rolling, flipping a H or a T. Not rolling, because we're not rolling a coin. So if the event is H, then the probability of getting an H would be just 1/2. And again, if the event was T, the probability of getting a T, again, is 1/2. Probability of heads is 1/2, probability of tails is 1/2. So rolling a die, what is the probability of each possible outcome? So the probability of rolling a 6 would be, you have a probability of 1 out of 6. Assuming the die is fair and that's equally rolled, then the probability would be 1/6. Same for 2, 3, 4, 5, 6. You have equal probability of 1/6. So what is the probability of rolling an odd number? So what is the event associated with an odd number? Well, that would be the event 1, 3, or 5. So if I want to look at the probability of that event, there's our event 1, 3, 5. I can write this set 1, 3, 5 as the union of the set 1, the set 3, and the set 5. All disjoint, so I can sum just the probability, so I get 1/6 plus 1/6 plus 1/6, so I get 1/2. The next lecture we will focus more on probability measure.